In today's Python video, we're going to be covering Kendall's Tau. We'll be going over a little bit of background information behind this correlation coefficient, the three different types of Kendall's Tau, a manual example, and then we're going to jump over to the Python coding side of things, where I'll show you in literally just a line of code where we can calculate Kendall's Tau A as well as B. So with this intro out of the way, let's go over a little bit more information about this correlation coefficient. All right, so there's some more information on Kendall's Tau. This is also known as the Kendall's rank correlation coefficient. Kendall's Tau is a nonparametric measure of correlation that assesses the strength and direction of association between two variables. It's going to be based on the ranks of data values. Because of that, it works well with ordinal data as well as small sample sizes, and it's preferred when data does not meet the assumptions of normality. And if it does meet the assumption of normality, right, and you don't have a lot of outliers, typically you'd want to use the Pearson correlation coefficient. But if outliers, it's not normal, you would want to use something like Kendall's Tau. There's three types of Kendall's Tau: A, B, and C. A, this variant does not account for ties. B, adjusts for ties and is the most commonly used version. C, adjusts for ties and differences in the number of rows and columns. When you use Scipy, you can use it for type A and B. So we won't be covering type C in this video. I do apologize, but if there is enough demand, I will make a type C video. I just don't think there will be, but let me know down below in the comment section. All right, so we have to talk about concordant, discordant, and also tied pairs. So concordant pairs is if the ranks for both variables are in the same order, discordant if the ranks for the two variables are in the opposite order, and then tied pairs if the ranks for one or both variables are going to be equal. Also, the strength of the correlation, right? Correlation can go from 1 to -1, so that's on the screen right now. You should be pretty familiar with that, but if you aren't, here is a good refresher. Here's the formula associated with it. So C is number of concordant pairs, D is the number of discordant pairs, T of X is the number of tied ranks in variable X, T of Y is number of tied ranks in variable Y. All right, so here's the steps. Number 1, rank the data, assign ranks to both variables. 2 is determine concordant, discordant, and tied pairs, compare each pair of values. And number 3 is compute the coefficient and use the formula on the last side to calculate that correlation coefficient, right? That one right over here. So this example is going to use Tau B. We have 5, 8, 2, 5, 5, 12, and 7, 8. So here we go. We have X and Y, right? We assign the ranks. Since we have two 5s over here, we assign the rank of 2.5. And then since we have two 8s on the other side, we assign the rank of 2.5. And here's the reason why. We would rank these 2 and 3, and then we divide it by 2. So 2 plus 3 is 5, divided by 2, 2.5. And we do that for both sides, right? Because they'd be both ranks 2 and 3. Okay, so now what we need to do is count concordant, discordant, and tied pairs. So we need to list all the different possible pairs out, right? And what we have those is pair 1, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. That's why we don't have a lot of numbers in this example, right? Because this balloons out quite a bit. Okay, so again, the rules for concordant, discordant, and then tied, right? If X or Y has the same equal ranks for the pair, it's going to be tied. Discordant, right? You see X of I is less than X of J, but then Y of I is greater than Y of J, and concordant is if Xi less than Xj, Yi is less than Yj. So just mapping these out right over here, right? You can see 2, 5 is greater than 1 for both of these. So we have concordant, right? Same direction of the sign. On the next one, we have 2, 5, and 2, 5. So we are tied in X. Then on the next one, we have 2, 5, and 2, 5 on the Y. So we're tied in Y. And then we have 1, 2, 5, 1, and 4. Well, the sign is in the same direction, so concordant. Again, 1, 4, 1, 2, 5. Sign is in the same direction, so concordant. And then lastly, right, 4 is greater than 2, 5 on both of these, but the signs are going to be different, right? Xj is greater, and then Yi is greater, so discordant. So if we go back, right, we have 3 concordant pairs, right, which is our first one over here, and then almost the last 2. Then we have 1 discordant, which is the last one, and then we have 1 tie in X, and then 1 tie in Y. So we just plug in all these values into this formula over here, and you get a value at the very end of 0.4. So this indicates a moderate positive association between x and y's. It shows more concordant pairs than discordant pairs, but ties reduce the strength of the correlation. So that is going to be our example. I know there's a lot of slides covering the manual example, but if you're only interested on the Python side of things, you can do all this in literally one line of code. I'll be showing you that shortly. So make sure you grab your notebook and let's get started coding. All right, so let's get going on this. Import numpy as np, and then from scipy.stats, import Kendall's Tau, like that. And I'm not gonna lie, guys, this is gonna probably be the easiest code for this entire statistics series. I'm not gonna reproduce those last slides. Instead, I'll just show you the two different variants with the help of Scipy. So what we'll do first is we're gonna go with our example from the slides. So we're gonna say example from slides, which is gonna be our tau of b, right? And let's get our x and y. So x equals np.array. And then inside over here, let's define that as 5. Oops, forgot the brackets. 5, then 2, then 5, and 7, right? And then we could do the same thing with y. Set your y over here. And then 8, 5, 8, 5, and it's 12 eighths. 12, also 8. Right. And then all we have to do is we'll say tau b, and then we'll have p value, which we're ignoring, but that's what we get. And we'll say Kendall Tau, and just pass in x and y, right? And what we're trying to do is find the value of 0.4, because that's what we had in the slides. So let's just print out tau b, and you can see 0.3999997 rounded to 0.4. So our math was correct on that slide. I do all that math when it's literally one line of code, right? But just to show you guys how that process works, I'm not sure whether they use Scipy, but that's B, right? One line of code. Let me show you how we can do A. There's a little bit of a variant on here. So we'll say tau A, and let's have different numbers this time. So we're going to say x equals np.array. And inside over here, let's say we have 12, 2, 1, 12, and 2. Okay. And then let's have y. And then inside our y, we'll have different values. We'll start off with 1. Then we'll look at 4, 7, 1, and 0. Okay. So we have both of those like that. And then let's copy this code. And instead of tau b, we'll call this as tau of a. And then we're going to have to add in another parameter over here. So if you want to get tau of a, you're going to have to add in a method. So we're going to say method equals, and then asymptotic, right? So grab that. I don't want to misspell it, so I'm going to grab it from my example code. And we have that over here. And then lastly, we can just print out tau of a. And check it out, negative 0.47, that correlation. So yeah, honestly, the code was quite simple, like a lot of these statistics videos, right? Manual gets complicated, but when you go and use what's been built out already in Scipy, you can apply these advanced statistical techniques in literally just a line of code. But yeah, that's about it. Hope you guys enjoyed this video on Kendall's Tau, and if you gained some value from this video, make sure to subscribe to the channel. Look, we're trying to upload at least 3 different data science focused videos every single week, and a subscription is free and helps us out. Now, if you want to continue our statistics playlist, we have a few videos linked down below in the description, and then you can click right over here to access the full playlist.